Oh, what's up, guys? How y'all doing? Whew. Hey, what's up, guys? My name is the Cherno. Welcome back to the final day of Vulkan Week. Oh, let me catch my breath. Just got back from the daily run. Final day. Oh, it's almost too good to be true. I mean, it's terrible, isn't it? It's such a shame. I was enjoying this so much. Oh, Friday morning. That is, in fact, what we're dealing with over here, right now. Oh. Blue Lightning, thank you for the 100 bits. Oh, how's everyone feeling? I'm feeling pretty good. I think this is going to be a fun day. We've got a lot of work ahead of ourselves, though, so let's not get too excited. But I'm looking forward to it because I think that it's going to be a blast. And I'm also fairly sure that we've done all the hard parts. So let's just do a little bit of a recap to those who are new, or have not caught the last couple days of streams. Let's see if we can set up the screen, maybe. So what we did last time was yesterday. Let's see what we did. So we moved everything into the Vulkan test layer. We did a lot of swap chain refactoring. We actually did a lot of work yesterday, like a ton. Day 4 was by far, I think, the best day. I mean, day 5 hasn't happened yet. It's happening here today, but I think it was by far the best day. Oh, Lord Rylif, or Rayliff, however you want to say that. Thank you for the 1-month subscription. Welcome to the stream. Hope you're doing well. Yesterday we basically refactored a whole bunch of stuff. We introduced Vulkan pipelines, and we even went as far as to do uniform buffers, but we're basically rendering an entire mesh. In fact, if I hit F5 so that we catch up with what we left off with last week, it was this. Sorry, last week. I'm just used to doing the game engine series. Yesterday, this thing, right? So we had this like sphere with like some really basic lighting. It's like one line of shader code, just a dot product of like a fictional light direction. But anyway, so we have this, which is pretty cool. But the thing is, it's actually going through our model system in Hazel. So actually, what I didn't do yesterday and what I could do now is try and shove a different model in there. So at the moment, I think, sorry, in Vulkan test layer, we are looking at the sphere mesh, but I believe, let's see if we can find something else, eh? Sandbox, assets, meshes, like the Cerberus, for example. So we should see that model now, I assume. I don't believe that submeshes will render at the moment. I'm not sure how that's set up. We'll probably have to think about that. That's probably something we can do today. But this only has one mesh in it, so this should render fine. But like an entire scene probably isn't going to render at the moment. All right, and check it out. So here we have our little model. Looks pretty good to me. So there it is. Cool. All right, so that's clearly working. So we're getting somewhere. Let's maybe go back to the sphere because it's slightly nicer to look at. Whew. So the big goal for today, though, is apart from being able to actually probably form some sort of Vulkan renderer so that I can throw it like a mesh or even an entity and it can handle the rest, and also render all of the sub-meshes correctly with their correct transforms, do all of the stuff that we want it to do. Apart from that, because that's going to be, I think that's going to be fairly trivial. The big thing that I want to do today is actually talk about. Well, actually, there probably is some shader reflection stuff that I want to do, but ultimately we need to get textures working, and we need to be able to, yeah, I just want to get textures working. And textures means both 2D textures as well as cube maps, because if we can do that, then we can do the, PBR shader, because that's really all we need. And also, we are using push constants, I believe, in the PBR shader. So we can set those up as well, but I'm pretty sure that'll be fairly trivial, surely. So yeah, lots of different stuff to do, but I'm feeling pretty good. So that should be good. Let's see, where was that sandbox assets shaders? I just want to look at the PBR shader quickly. Yeah, so we have uniform binding 0, which is the camera, which should work, and then transform, which we need to give it. That's it. And then over here, we obviously need to take care of, well, there's the environment, but then these are push constants, these material parameters. So we need to deal with the material parameters, all right? The Cerberus gun, I don't know, it's from the internet. If you Google it somewhere, you'll find it. Just type in like Cerberus or something like that. Cerberus PBR model. Forgot the name of the author of it. So yeah, so that's ultimately the plan for today, I think. So textures is the big thing that we're going to be doing, but also I would like to get submeshes rendering, and also I would like to maybe get some of the stuff from reflection, and then I guess maybe frame buffers and stuff like that, but that's going to be a little bit trickier. Now, in terms of, let's take a look at this quickly. In terms of, how we do index, like how we do submesh drawing, you can actually, there actually is a vertex offset here and a first index here, right? They're both set to 0, so that's actually like solved, basically. We can actually do this, and we can probably, I don't know if we switch pipelines between that. Not sure, I guess you would maybe switch pipelines between that. And also, I'm not sure when we can set uniforms. So that's gonna be something to, yeah, Andrew Maximov, that sounds familiar. Someone found it, thank you. Yeah, so the way that we, do this whole rendering thing, we should probably move that into like a different renderer. I think if we look at Hazel's renderer at the moment, renderer.cpp. So this is kind of OpenGL at the moment. So you can see the way we currently render this mesh, excluding animation, is we basically, well, and this isn't really correct, so I don't mind rethinking this whole approach, to be honest, but basically we have all of our like vertex buffer, pipeline, index buffer that we bind. Pipeline contains a shader as well, I believe. Actually, what is binding? Oh, no, this sets up the vertex, in OpenGL, this sets up the vertex array, like layout and everything like that. But then we set the uniform buffer transform, which is a uniform buffer in OpenGL as well. And then we do render submit, and then we actually do like, you know, GL enable, GL depth test, and then GL draw elements based vertex. So GL draw elements based vertex is what we need, which is obviously takes in an index for the base vertex as well as an index buffer offset. But that's easy because obviously we have base index, we have base vertex, and we can just pump that right into this, right? Because this also has a vertex offset and a first index. So I think that's easy. So what we can do actually to emulate that somewhat is, because we have mesh here, right? Is we could just do for submesh, mesh, mesh, submeshes. Right? And then I'm using brown switches, yeah. And then from here we can probably do, so what's that? That's the first index. Let's call this submesh, so it's less confusing. Submesh.base index, and that's the vertex offset. Submesh.base vertex. I assume they're just indices, both of them. Like, sorry, that like they're indexes, like they're not like pointers or byte offsets or anything. And that's it. I mean, usually you'd have to probably think about different pipelines because they might use different shaders, but let's just hit F5 on that, and then we'll try and load in a model maybe that has 3 things. Or like, I think we have one of the test models, I think, the test scene, yeah, that should have like, I think 5 meshes in it. All right, this still renders. And now meshes test scene.fbx. So the question here is, will we see all of them? Where's my test scene.fbx? Yeah, so spare cross is only being used for OpenGL. It's not being used for Vulkan. Because we can just compile normally. Oh, this doesn't work. This little device loss thing again. Huh, I wonder why. So last time we got a device loss because we didn't have a... I hate this. Yeah, we need to enable better validation, don't we? Let me just actually look at the documentation for this command, maybe. Because I just want us to make sure that base index is the value added to the vertex index before indexing into the vertex buffer. Yeah, indexing in, so that's... seems okay. Ah, we're doing this. This is wrong. So we actually need to ask it what the indexed count is. Vulkan does use GLSL. Vulkan has its own kind of GLSL semantics that put some other like concepts into GLSL, into the language. But in general, it's still GLSL. That's what it uses. Oh, okay, that actually worked. You guys might not believe me, but that worked. Because the thing that we're not doing, that we should be doing, is actually setting the uniform buffer to be different values per draw. Because obviously we're not doing the transform at all. So let's try and do that. That's going to be tough though. Let's see if we can do that. So we're basically building a very basic renderer at this point. If we hop on over, excuse me, to Vulkan Triangle, then we can add another one of these, which is, so now we're kind of going along with our PBR shader, because that's what it has as well. And this one's called transform, and this is called transform. I guess we can do u underscore or something to be. Just let's clear that it's a uniform. U transform. Okay, so now we have another uniform buffer binding 1. And this is gonna let us hopefully rethink how we do our shaders, because as I mentioned, the way that we do our shaders at the moment is a little bit dodgy. Man, this is so slow. I should restart Visual Studio or something. Oh, the pineapple, thank you. We're up and running. That's why nothing was working. I'm kidding, everything was fine. Okay, so we've got a uniform buffer. So how do we add another uniform buffer? Well, and again, this would happen by reflection, but I guess we just, so we have a layout binding. Is that really what we want though? And where's the descriptor set stuff? So we could probably do that, right? Can we do that? Yeah, probably. And then we'll do the same thing for binding 1. So this will be on binding 1. And we'll do a different uniform buffer. But now we can do descriptor sets, and there's obviously 2 of them. So we're expanding this, and this is just, again, to help me understand exactly how this is going to work in the future. Let's change this so that create uniform buffer returns a uniform buffer. I mean, it already does, but I think the way we're handling it, it doesn't. So uniform buffer. Return uniform buffer. All right, and then so now, instead of doing all of that, where did we create the uniform buffer? Here it is. uniform buffers. We'll just create 2 here. And then this will obviously be, but I think we have to actually, we do have to assign them here. We should assign them here. So we can get rid of this. This becomes that. This becomes uniform buffer 0. Uniform buffers 0. Whoa. Descriptor, and this becomes uniform buffer 1 descriptor. Okay, and then finally we need the map uniform buffers thing. So see, this had a binding point, which we didn't use at the time, but now we do. So Pastrano thought of this, which is nice. Always nice when Pastrano is considerate. And then this will again be the binding point. All right, sweet. So now we should have 2 uniform buffers. I probably missed some stuff. Like there was some stuff I noticed in the descriptor set layout. So we can just say that there's 2 uniform buffers in the vertex stage, and then I guess that's it, and we just have a single binding. I guess that works, right? Not sure. We could look at Sasha Willem's example. I don't know if he had 2. No, he just had a single one in here. I'm sure maybe the IBL example maybe had multiple. No, that's not what I want. Nah, he just had the single one. Alright. Alright, well, okay, we definitely need to take a look at Vulkan validation because I'm scared, you know? Okay, so what about this though? So there's obviously 2 descriptors here, and then, okay, no, hang on, descriptor pool size. So does this really, there's 2 uniform buffers? We have to write that here as well? See, I'm getting slightly confused now. And then what's this? Descriptor set layout. Descriptor count equals 2. Oh, this is fun. Okay, I'm getting a little bit confused here. So, uniform buffers, we have 2 in the vertex stage. Descriptor layouts, though, what's that? I don't remember. And we have 2 we have binding count of 1 apparently, layout binding. I guess, well, yeah, that's correct because we have 1 of these. So that's fine, and that's us creating a descriptor set layout. So that's our descriptor set layout. Let me just write this so it's more readable. Okay, and we'll have a little bit of a divider here, just so that it's super clear what's up. And then, after that, we're gonna do something else. I like having these things here, because sometimes it's difficult to quickly scan through a section and see what's up. This is the uniform buffer stuff. And this is the descriptor pool. Right. And then these are the descriptor sets. Okay, I'm already feeling better about this. Okay, and then we'll do the right descriptor sets. Yeah, which we already did, I think. And that has the binding and stuff. This is okay, but this, I guess we need 2 descriptor sets though, right? In the pool, is that how it works? Well, we have a pool, but now we're trying to allocate descriptor sets. So yeah, we need 2. And then what that's going in here. So is a descriptor set a set of like descriptors? Because it looks like I have 2 here, and I guess we're writing 2 here. I don't know, man. Again, this is where validation would definitely help. But if I did everything correctly, which I highly doubt, like seriously, this is one of those things where I'm like, maybe it'll work. I'm pretty sure this won't work. But nevertheless, let's try and map that buffer. And let's do, well, we don't need the view projection can obviously be done elsewhere. Just keeping everything scoped here so that we don't leak variables. Map uniform buffer 1, and this time we'll set it to submesh. Submesh dot transform. I'll just save a little bit there. There we go. All right, so now maybe we've got the transform. Well, we should have the transform. Yeah. Okay, so what's up here? Okay, I really need to have the validation layer. I don't understand why the validation layer isn't working. I thought it was. I've seen stuff from it, unless I'm crazy. I need to find an example with 2 uniform buffers, I think. Like, why? Maybe the scene rendering has 2 uniform buffers. It has to, right? Maybe here? But that wasn't... I don't think that was correct either. Nah, push constant. See, he's doing the model matrix as a push constant, which kind of makes sense, but the thing is, I'm not sure if that's realistic for me to do because, again, like a push constant, you have 128 bytes of push constants, maybe 256 depending on the driver, but 128 is the official minimum requirement. So that's half gone, you know? Half. One matrix takes up half. So I don't know, for a more complex rendering scenario with like PBR, you may run out, maybe not, we'll see. Anyway, I feel better about putting matrices in uniform buffers for now because of that, because 2 matrices is all you get in terms of push constants. Deferred rendering, maybe something here. Could have... No, he's putting everything into a single one. I mean, I guess technically you could put everything into the single one and then just update it based on an offset, right? I'm not sure what's better. Like, I'm not sure what's better at all. Anyway, back to our code. But I still want to make this work as well because we should be able to handle multiple uniform buffers. Okay, let's go back to the Vulkan validation because I feel like we're just gonna waste time if we don't do that. Vulkan 1.2, how to enable validation. I don't really want to set global environment variables here. VK create instance. Well, maybe I don't need this stuff anymore because it's coordinate now, but I don't know, we'll see. So create instance. So what, instance create info is supposed to do that? Maybe they've changed it? I doubt it. Let's see what happens to this. Let's see what happens here. with this stuff. We could try and like list all of these, because I don't know, maybe validation layers aren't present ever. Oh, well, it would have printed that, wouldn't it? Have. Render.capture, Valve Steam overlay, Steam fossilize, EOS overlay, device simulation. I don't know what that one was. Standard, there it is, standard validation. So it uses that, but is that still the go-to? Because I guess it does enable it, according to this. So we should have it enabled. We created the instance with that layer, like, enabled. Apparently we also need debug report extension? Really? Let's just print all of these things, eh? But these are not extensions, they're layers. Ah, here it is. Yeah, debug report. So this stuff gets enabled, right? Well, I guess pushed back. I guess I could see if it's present or not, because maybe this has changed names or something, although they're still here actually. But we can always, I think, check, right? Did we do this inside the device? Maybe the device should. Nah, it's an instance level thing. Maybe I can enumerate the instance extensions. Well, I don't know, man. We've got 4 of them here. If validation is set to true, we definitely create it with a validation layer. But like, I don't know, this just never happens. Like, it just doesn't work. Like, here we trigger a breakpoint because of VK check result. But that's like, you know, that's us just checking the result. So wouldn't this, if validation was on, this would have printed something, surely. Debug utils messenger is the newer recommended way. I thought it changed to VK layer Kronos validation. Maybe. How am I supposed to know that? So let's do this. Let's just do Hazel core trace. Layer name. So we'll dump all of the layers. There is a Kronos validation one. What if we enable that one? Let's just try this. Definitely layer Chronos validation. Okay, maybe the Luna one was for like Vulkan 1.0, 1.1 or something. Hey, we did it. Yep, alright. Awesome. We're getting some debug messages now. Oh. Turns out our super clean engine is not very good. Awesome. Thank you, guys. Alright, so what's happening here? Probably unset variables. Alright, let's go through and fix some of these, actually. Yeah, I'm sure there's a lot of unset variables, to be honest. Because I'm not initializing a lot of my structs like I should be. Why is it so slow? So what was this? I didn't actually let it print the message. Good one, Chano. Let's print the message. F10. Let's go back here. So message is VK create device, P create info, Q create infos, Q priorities. So our Q priorities are not set, it looks like. What should they be even set to? So device create info, Q create infos, right? It's in here actually. MQ create infos inside the physical device, which is actually here, I think. MQ create infos. So it's this, right? The Q priorities is default Q priority, which is 0. Oh, but wait, what? No, that should be fine. It should copy it at that point. And it's set to 0. So wait, when are these? No, I think I know what the problem is. When are these created? It's just pushed into Q create infos. Oh, it happens later in the Vulkan device. Alright, well, we can probably make this static, and that will probably fix that error. Okay, VK render pass object is invalid. Inside swap chain create frame buffer. Huh. How odd. Frame buffer create info render pass. The render pass hasn't been created yet. When do we create the render pass? Here apparently. So frame buffer maybe should get created after the render pass gets created. Let's try that. Okay, next issue. Descriptor set layout is wrong. This is great. I don't know how we lived without this. We solved so many problems without using this as well. Oh, good. We're in the shader now. Okay, so apparently some descriptor set wasn't set. Okay. So descriptor set layout is CD, which means it hasn't been set yet. Descriptor set layout. What's... Oh, because there's 2 of them. We need 2 layouts. Okay, we actually do need 2 layouts. Well, yeah, because we've said 2 here. Do we really need 2 layouts though? I guess the descriptor set layout is for a single descriptor set. Am I correct with that? It's just, I thought that, nah, but but why does this contain 2 descriptors then? I think maybe descriptor set count should still be 1 in this case. See, this is this is a little bit iffy. Like, I'm not really sure. Yeah, 1 layout for multiple descriptors. That's what I would have thought because they're the same. So maybe descriptor set count should be 1 then, because otherwise it seems to expect 2 layouts. Unless I'm misreading that. Yeah, this is a different error. VK update descriptor sets, failed to write validation for VK descriptor set with error, blah, blah, blah. Descriptor set allocated with descriptor set layout does not have binding 1. So a descriptor set allocated with the descriptor set layout does not have binding 1. So does that mean my layout doesn't support binding 1? But there's nothing... binding count. Maybe binding count should be 2. No, isn't that what I did earlier? No, I did descriptor set count. But yeah, binding count should definitely be 2. I'll bring this stuff out into variables. What is the most problematic performance bottleneck Vulkan solves in your engine compared to OpenGL 3? Well, at the moment, nothing. It's just going to let me do ray tracing, which I want to do. And also, the architecture of Vulkan is a lot better than OpenGL. So it's better to write a good. It's easier to write a good cross API compatible renderer inside Vulkan compared to OpenGL, which you have to do a lot of crazy stuff for, which is really annoying. All right. So descriptor type of binding 1 doesn't fall between a certain range, so I probably just haven't set that. Where is that coming from exactly? Here, create descriptor set layout. So it's not happy because of the binding. I guess we need 2 bindings here. But why? I've set 2 descriptors. Or does that, what does that mean? Descriptor set layout bindings. Does that mean 2 bindings, 1 for each? Maybe I need 2 of these, to be honest. Anyway, I should probably like look up some documentation because I am just guessing my way through this. But let's try this. Because they are different binding points. So that's my theory. Oh, here we go. The Giagi is saying that I need 2. Binding yeah, that makes sense. I just missed something. Oh, it's still here. Maybe not. Maybe I don't need 2 different layout bindings because it's. Maybe I need different layout bindings for different like types. Because if they're both uniform buffers, surely 1 is enough. In which case, let's take that away. Let's just leave it like that for now though. So now it's not happy because descriptor set layout does not have binding 1. So the descriptor set layout really does have to have something in binding 1 then, I guess. So where is our descriptor set layout? Here it is. That's our layout binding. Okay, create just, here it is. Okay, yeah, and description select. Okay, binding counts. So then this does actually have to have 2, I guess, right? Because this clearly is saying that there's nothing at binding 1. So maybe if we go back to here, because I know that he created multiple of these for like, because you need them for image samples and stuff. Is that it? No, okay, so yeah, so there are multiple for uniform buffers as well here. 0 and then 1 and then so on. And this creates them, yeah, with all this stuff here. Vertex and fragment for this one. Yeah, okay, so we do need multiple descriptor set layout bindings, it seems. So that's fine. So let's do 2 of these then. But then descriptor count, I guess, is 1 for both of them. What happened here? One, yeah, 1 is the default one. Yep. Alright, so let's do that. Let's do this. So that's to 2. Okay, so what didn't work here? Sorry. Where's this coming from? Call stack. Ah, it's coming from here. All right, what's the issue? Duplicated binding number. I'm just an idiot here. Wait, from here there was a duplicated binding. Oh, what's the binding point? What? I don't know why binding was missing from there. I guess because it was 0 by default. Maybe that was the initial issue. Yeah, thanks for the diagram, Binary Breakpoint. Took a brief look at it, but I think I get it. I think it's just the API stuff that I'm a little bit confused about. Whew. Oh my gosh, we ran. I mean, it didn't work, but we ran without any issues. That's odd. Oh, we didn't recompile our shaders. They were still in the cache. Layout bindings are still indexed 0 in the first one. Okay, I'll take a look at that after I see if this works or not. Oh. Whoa, well something worked. Alright, layout bindings are still index 0 in the first one. Layout bindings is still index 0. Layout bindings. Where are the layout bindings? Where am I? Layout bindings is still 0 in the first one. Not even sure what that means. That looks fine to me. Binding 0, binding 1, descriptor 1, 1, 0, 1. Seems fine. 2 descriptors here. Pool size count max set, I guess that's all fine. Descriptor sets, and then this is 0 and 1. Destination binding 0 and 1. Uniform buffer. Let's get rid of that. Doesn't make sense anymore. Yeah, that looks fine. Where? I don't see that. Layout binding 1 instead of layout binding 0. Where? Oh, these. Thank you. But it wouldn't have mattered. Because it's 0 by default. It's weird that didn't work. Like, because it seems like it half worked. That's the problem. Where's my shader? Yeah, like, it seems like, I mean, the scale kind of seems to have worked because that's the correct scale, right? But then it's made that flat. That's so bizarre. That is so bizarre. How am I making my uniform buffers? Seems fine to me. Also seems fine. Very strange. I'm not sure why that's not working. That should be working. Unless this stuff like needs to be done in a different order. But I'm pretty sure you can change uniform buffers whenever. Well, I'm not 100% sure, but like you can unmap them and then draw, right? Or maybe not, I don't know. So when does this happen? On view changed, and then draw. Does it submit? Yeah, I don't care about that. Because this doesn't do anything. Do I use calculus often in my code? Probably not. Depends what you're doing. For graphics programming, you need more like, you know, algebra and vector maths and matrices, I guess, and stuff like that. That's a lot more useful. Vector related stuff is very important to know well. Calculus probably not so much. At least not for me personally. So weird. I don't think this is helpful. I guess uniform buffers can't be updated at that point. I guess you have to do that before a render pass or something like that. In which case, you obviously need to use push constants. You need to allocate a descriptor for each object and bind a different uniform buffer to each. Nah, I don't buy that. What do you mean for each object? So this is probably something you would typically do like... Oh, well, I actually am doing it here. So what if I didn't do it here? Maybe then we wouldn't see anything. But yeah, it's weird that something's happening, so it's a bit weird. No, we still see what we do before. So something's happening. My current theory is just that you can't do that when you're in the middle of a command buffer or a render pass. You have to do it before. Which makes sense to me, because that's how push constants differ. In which case... if we look at... we can do VK command push constants instead. For this stuff. I guess we'd have to, right? Pipeline layout. Layout. Stage flags. Offset, size and values. Size of GLM mat4 values submesh dot transform. All right, so let's try that instead. And then, unfortunately, that screws everything else up, but it's okay, I guess. We should have tested it. Yeah, I can actually I think I can leave everything else in the shader, right? As long as I go back. We'll still leave this at binding transform and like UB uniform buffer transform, but then I'll just do layout push constant uniform. Do we need uniform? I guess so. Transform. Oh, wait, this is UB transform. And then this will be my U transform now. Right, and then that, I think, is gonna just work. That should work. Just, I just wasn't sure whether or not push constants was something I wanted to do at this stage, just because, again, we have 128 bytes only guaranteed, and that's half gone already, because it's a transform matrix. Oh, validation. Push cons overlapping offset 0 and size 64 do not contain stage flags. Oh, well, first of all, actually, how on earth does it know which push constant I'm pushing? Hold on. This is probably something I should have... We probably need a descriptor set for the push constant or something like that. Can't just add a push constant like that, I think. So, let's see. Or is that part of the pipeline rather than... Huh. It seems like it's part of the pipeline. But does the descriptor set layout say anything about push constants? Doesn't look like it. It's got image samplers and it's got... Yeah. I guess not. But the pipeline layout does have something about push constants, as we saw. It's got push constant pipeline layout, push constant range count 1, and then push constant ranges are just which one you're dealing with. Interesting. So we just need to add a push constant range count of 1, and then push constant dot push constant ranges, and then we can set that up here, I think, if we just so vertex, yeah, size of push block, and then that's the push block. All right, cool. So this is what we want. Maybe that will work. There we go. Okay, so using push constants, that was pretty easy actually. I feel like the lighting was flipped though. That's weird. But using push constants was pretty easy as expected, but I did kind of want to use uniform buffers for that, but I guess that's okay. So, okay, long story short then, as far as I understand it, uniform buffers cannot be changed in either a command buffer or in the middle of a render pass, which is fair enough because I guess that's the difference between push constants and uniform buffers. But that also means, do we just put our transform into the uniform buffer? Sorry, do we just put the transform into the push constant? I don't know. What do people do usually? Yeah, well that's what I figured with uniform buffers. It just didn't like bring up any validation issues, so I was like, I don't know. I expected it to be like, hey man, you're in the middle of a buffer, like you're trying to edit. Well, I guess it's because it doesn't matter. It doesn't know that I'm trying to edit that one maybe. But it could have validated that a little bit better maybe. Alright, well, if that's the case, then that's fine. We can leave it as is for now. So let's actually go to the OpenGL shader then. Sorry, why am I going to OpenGL shader? Let's actually go to the Vulkan shader and start refactoring some of the code so that it's a little bit more dynamic, because I don't like the fact that it can't deal with our things for us. So reflect, let's actually have it reflect maybe. So this is like the working code and we've done all that, but what I want to know now is basically if we go to OpenGL shader, that has some reflection stuff. Oh my gosh, Visual Studio is so slow. Yeah, it's like this stuff. It's very cross, and it can just take in the shader data. So the shaded data we can keep around. Where does that even come from? Here. Actually, this is so slow. Maybe I should just restart Visual Studio, or maybe 17 gig. Maybe I'm running out of disk space. Okay, let's close that. So that's our vertex shader, right? So we can get the shader resources. Let's go back to actually the OpenGL shader and see how we do everything there. Yeah, I guess I can keep that as auto. Let's move this over here. Okay, so this is gonna give us all of our uniform buffers, right? Let's start logging this stuff. Alright, so I want to know all of the uniform buffers. Probably print the name of the shader. Let's see. So, uniform buffers. Where's the name? Why do we not have the name? So let's do name. Name. Do we care about the type? Don't know. Member count. Member count. Binding point. What is the type going to be anyway? What's this? Spur type. Spur type. I think we have that here. But like, I don't understand. Like, that's not gonna... Unless it's like this particular member. Yeah, if we're going through like member types and stuff. I don't think we need buffer type. Do we use that anywhere here? Probably not, right? Electron diffuser, what's up? Welcome. Welcome back. Got two moderators in here now, excluding Nightbot. Okay, we do use the buffer type to get the size in bytes. So that's interesting. So buffer type can be used to get the size. Get declared struct size buffer type. Oh, and I guess we need the member count. Yeah, we'll keep that up here as well. Okay, so that's maybe going through all of that, and then I know that we also went through push constants because we had to. Yep, push constant buffers. Here they are. Let's just copy this entire block for now. I want to rename this to compiler actually. Don't like shortening names all the time. Easier to read this way. Okay. So yeah, this stuff was for OpenGL. And we actually went through all the members, which we could do for uniform buffers as well, but let's not get too ahead of ourselves here. Okay, so let's think about this. Let's do, and this can have a location. Push constants with location. Push constants with location. Why location? Was that used anywhere? Nah, it wasn't. Alright, I'll get rid of that, because it's probably not going to have a decoration location. Okay, push constants. Push constant buffers, we'll call it, because that's what it's called. And then we'll grab this stuff for now. Name. Binding point. Now, binding points. Do we care about binding points for push constants? I'm not sure, actually. How did we... That wasn't a Vulkan shader, actually. How did we... No, that was in the pipeline. How do we deal with that? Because I'm pretty sure we just added in push constant with an offset, and that's it. You can only have one little group of push constants, can't you? You just have push constants and that's it. Is that how it works? You can't just have like multiple push constant buffers? But I guess you can, right? Because why would there be a list of them then? And if so, do they have binding points? Because this shader reflection stuff seems to go through a list of push constant buffers. So, unless, like, that's just a weird scenario that might exist maybe? I don't know. Because I haven't been specifying bindings for it. Like, I've just done layout push constants, not like I'm doing binding equals 1. But maybe you can do that, and maybe you can have different ones. I'm not sure. Just something I'm not sure about. Okay, member count is member count. Binding point is, well... not really in use. Size is... what size? Size we don't have. Should be able to get the size from the buffer type again. And then here are our members, which we probably won't talk about now. Let's give this a go. Just want to see what we what kind of reflection data we get from this. Okay, so Vulkan shader reflection, Vulkan triangle GLSL, so uniform buffers. We have 2. So camera, 1 count, yeah, that's all correct, yeah, and then no name for our push constant buffer. Why not? Compiler get member. No, sorry, this is it. Resource.name. Why no name? That's sad. I had a name, it's this. I guess it doesn't matter what the name is, right? Because you can't, if you can't have multiple, then what's the point of names? Not sure though. Member count 1, size 64. Put a little divider here. And I guess I also want to get the... I also want to get the, what's it called? The attributes. Okay, well that's pretty clear. I don't know why yeah, I guess names are not supported or something, I'm not sure. Alright, whatever. So now that we have the uniform buffers though, we should be able to... Okay, so remember, descriptor, if we look at this, so descriptor sets shouldn't be in the shader class, we decided, I think. Right? Because this, why? Because this needs a uniform buffer descriptor? Why did we decide that these shouldn't be in the shader class? Just because uniform buffers are not per shader. Maybe that's why. But let's see, use the descriptor set and uniform buffer descriptor. Really? Why shouldn't this be in the shader? VK update descriptor sets, M descriptor set. This music is, this is called Magic Armchair by Sugar Rose. It's just like part of the jazz playlist on Epidemic Sound, smooth jazz. I think ultimately the reason is that we don't want the shader to be responsible for resources, right? So the thing is, this is fine for now, but if we try and expand this with a texture, then it means that we need to, as far as I'm concerned, it means that we need to actually write the texture into this descriptor set, which obviously we don't want to do in the shader. So I feel like these descriptor sets need to be handled differently. So if we look at let's look at a basic texture example maybe. So texture, I guess, is a good start. So if we look at the shader has a binding 1 uniform sampler 2D. Binding 1, really? So you have to have different bindings across all resources, really? I was not under that impression at all. I thought it was per resource type. Okay, interesting. Anyway, this texture, so the way I expect this happens is that these write descriptor sets, yeah, so there's one for the uniform buffer, there's one for the image sampler, but see the thing is, there has to be a texture descriptor for the texture. So you actually need the texture's view, sampler, and image layout. So you need the texture to create a descriptor so that you can then, like, use that. So that's worrying because it obviously means that you can't have it here. So the Giagi is saying that each entity should have its own descriptor set, and I guess that's what I'm seeing based on this. That it seems like since you need a specific texture, when you say load a model, when you load a mesh rather, when you load a mesh and you want to render it, then I guess in Vulkan you can't really just be like, hey, let's bind this arbitrary texture to this slot, like in OpenGL or other APIs as well. I think it's more like you have to upfront make sure that you have that descriptor set. But then when you update these descriptor sets, what exactly are you updating them for? Like a particular... Well, actually, this is a better question. It's fine that you're doing this, but where are you accessing the descriptor sets? So this is M descriptor set, right? And we're writing them, and they're basically going to M descriptor set. So where do we use the descriptor set? That's what I want to know. And I think the descriptor set is used inside our drawer here when we actually bind descriptor sets. So that means that before you render something, you would basically bind a separate descriptor set. And then you would have a unique one per object, I guess. Which is a little bit, like, wasteful almost. Flick Shizzy, thank you for the $5 donation. It's probably a little way down the road, but this guy's post helped me a ton with descriptor set management. I wish I could select that link. Can you paste that link in chat? But thank you. Thank you, I got it. All right, let's take a look at this. Blue Lightning, thank you for the 100 bits as well. Appreciate it. Okay, so Granite's Vulkan backend. All right. Mm-hmm. Yep. Okay, let's skip to descriptor sets maybe. Or is this just all about it? Creating a pipeline, blah, blah, blah. Rather than manually declaring the pipeline layout like a caveman, I think using reflection to automatically generate layouts is a good idea. That's what I'm doing. There is no reason for users to copy information which exists in the shaders already. For the reflection, I use Spurvy Cross, same. If we never need to compile Spurvy at runtime, game engine scenario, there is no reason why we cannot shift the reflection step to offline as well. Yep. And just pass the sideband data along to remove a runtime dependency. I never got as far as building a nice offline Spurvy baking pipeline, but I just compile just on the fly with shaders C. That's what I do as well. However, the interface, except I'm caching them. But yeah, like the shader reflection stuff ultimately would be done offline because again, if your shaders aren't changing, why do all the reflection online? It wouldn't typically be done, but obviously we're dealing with a game engine like level editor or like just a general editor, which should be able to compile shaders on the fly for sure, because if you're developing the game and not running the game, then obviously you want to be able to change things like shaders and not have to like say run some offline tool manually and then reload everything. Like that's a mess. It should just be able to handle that stuff if you're working on it. But obviously for a game's runtime, you should be taking in already compiled shaders, already compiled information about the reflection stuff, which could be part of the shader, which could be part of like your own custom shader format or something like that. So that all makes sense. Common mistake beginners tend to do is think that names are important in binding interfaces. Yeah, that's clearly not the case because we have like bindings and location decorations. Absolutely. This is the only reason I was trying to get the name earlier is just for our sake. We need to create binding interfaces, pipeline layouts. Yeah, pipeline layout in Vulkan needs to know all shader stages. So we need to combine shaders into a Vulkan program. Okay. Here we take the union reflection and request handled from descriptor set allocator and pipeline layout. This is hashed, but there is no performance consent here, since we should do all of this work in load time when possible anyways. These handles are all owned internally in Vulkan device. There is no reason to worry about object lifetime for these objects. Okay, so I guess this is done per shader. I don't think there is a reason to deviate far from this design unless you have a very specific. Okay, so just so I'm understanding correctly, pipeline layout in Vulkan needs to know all shader stages, of course. We take the union of reflection information and request handles and request handles for descriptor set allocator and pipeline layout and hash it. Okay. The binding model. Never really had a problem with the old school way of binding resources to binding slots. It just isn't part of the old APIs. I felt we're lacking. Yeah, I kind of agree here. Granite is kind of old school here, but it does have full consideration for descriptor sets, and I removed any impedance mismatch with Vulkan, i.e. no translation needed to bridge between Granite and Vulkan. So command set storage buffer and set texture. The old binding models in GLD3D11 have flat binding spaces with no separation of per frame, per material, per draw bindings. Granted, I want to take full advantage of the descriptor set feature, where we can assign some kind of frequency and relation between bindings. Okay, I might look at this actually. So what is this Granite thing? Some kind of engine, I guess. Just want to see how far advanced this thing is. My personal Vulkan renderer project. I see. Cool, this might be nice to look at. I wish there was like an image, a pretty image of something beautiful being rendered. I mean, I guess Hazel doesn't have that either. Cool. I don't know if this is going to be useful to look at though. Interesting. All right. Good night, Cybercyclonic. Thanks for hanging around. Some dude's renderer. Cool. Some dude's renderer. Okay, cool. Thanks for the helpful information. I might refer to that a bit later. Okay, so I get all of that stuff at the moment, I think, at least. Yeah, so we need the descriptor set layout, and I guess push constants we can also get from the shader when we create the pipeline, which is what happens here. So I think what we should do before we get too deep into this, because this currently works, doesn't it, is try and get texture. Try and get texture. Try and get textures working. Alright, so we got this. I still don't know why that light is suddenly upside down. I mean, it's not really a real light, but it's weird that it's switched. Okay, so we got push constants and all that stuff. Let's try and get textures to work. And I don't think we'll be able to get all the cube stuff working. I mean, we might, but realistically, the reason why I'm suspicious is just because, like, that all happens via a compute shader, and we have to, I don't know if I'll be able to, that's just going to take some time, that's all. So what we'll do is, let's scoot on over to textures and add Vulkan textures, which I might refer to my own example to do actually, because I've done that before. So Vulkan texture, I think that will contain all of the textures for Vulkan, not just 2D. Please work with me, faster Visual Studio. Now, well, why would we switch away from GLFW? Like, what's wrong with GLFW? I don't understand. I don't like to do things just for the sake of doing them, unless, like, it's very beneficial. Especially because our resources are limited. So this is, we'll do Vulkan texture 2D, obviously. Include Hazel renderer texture. Alright, and let's refer to my example, because I think I did textures, yep. And I don't know if this is good or not, but we'll see. This is what we ended up having for it. I'll just copy everything for now, maybe, and then we'll see if we need to delete some stuff or clean it up. So, that stuff is pretty good. Let's include, maybe over here, Vulkan.h, which is all of our stuff for Vulkan. need the context. I think we just need the device. Actually, I think it's get current device, get Vulkan device. So I guess we do need Vulkan context. Really? Const? That's weird. I swear I wasn't doing that earlier. Maybe I'm doing the wrong thing. Buffer. Let's look at that. Because I use the device stuff. Oh, it's just auto device. Alright, I wasn't doing a reference. Fair enough. Don't need to. It's a reference counted object. I need to do this on the render thread as well. Alright, so this stuff's gone now. Let's just get rid of that. Now we have an allocator. We have a memory allocator as well. So Vulkan allocator, allocator, texture 2D. Allocator dot allocate memory requirements. I don't know if we need to do this. This is using staging, I think. Yes, it definitely is. Okay, fine. And we need to make our other buffers use staging as well. Okay, clearly we're doing RGBA only here, which is okay for now, maybe. So let's do channels equals 4 here. Just to remind ourselves to change that later. Lots of stuff here. What's this now? Oh, this is still part of the staging stuff. We need a command buffer to execute this though. Oh my gosh. There's so much stuff here. Why is it so big? Goodness me. So what do we do? We did get command buffer true. This probably created a new command buffer for ourselves from the context. Let's just take a look at this quickly. So get command buffer and then begin. So yeah, this full on just gets a new command buffer for ourselves. I guess we probably want this. This should be done on the device, not on the context though. So let's get that from the device maybe. And then so what I'll do is let's copy this. Vulkan device. And then let's take a look here. Vulkan device. Get command buffer. Begin just begins it, I think. Command pool. Do we not have a command pool? Is that on the context? No. I think we do have a command pool. I think it's just not showing up here. Yeah, we do. Not showing up because we haven't made the actual function yet. And then we also have some other functions like flush command buffer, which again, we use some fences here and stuff. So I'm a little unsure if we want to do it this way. And we also have end command buffer, which we kind of need, but flush should maybe do that. We have an active command buffer as well. Yeah, I don't know if we'll do that. We've heard this song a billion times. Oh, this actually doesn't end. Okay, cool. Well, that's fine then. I don't know if this will work. Let's just see. And then texture can do that stuff. Now, since we need the device for that, let's do that. Vulkan device. Right? And then this will just do that. And then that way when we do this stuff, we can just do... Again, I do kind of want to abstract some of this stuff. I'm not doing it at the moment just because I want to actually understand a little bit more about how Vulkan works. Okay, so this is device, get command buffer. Which makes more sense. Vulkan device. Device, flush command buffer. Vulkan device. Vulkan device, Vulkan device. Alright, cool. So, device is not going to be that anymore. Device is, well, I guess this is kind of what we want. But since we only need the Vulkan device here, might as well just tack that on. Alright. So, we basically do have some situation with textures working, maybe. No clue, man. No clue. We need to make sure that this stuff actually happens on the GPU, though. Like, as in on the render command queue. So I don't know how we're going to do that. How do we do that with? Actually, how do we do that with OpenGL textures? Do we just do the load on the GPU thread? No, I don't think so. I think we loaded it into the CPU and then we had image data here. All right, that makes me feel a little bit better. So we did the load on the CPU thread and then we give that data to the GPU thread. Cool. So, image data is what we had, which is just a Hazel buffer. Getting hungry. No breakfast churno is back at it again. How on earth does the size get set? I don't think it does. That's probably why we shouldn't be doing it like this. Oh, I mean we can, but should just probably set the size to like this or something. Which is not ideal, but it's not bad as well. Okay, so now we can do Vulkan ref. We can make a ref from ourselves now. Instance equals this, and we can just say renderer submit. All of this junk. Junk. Let's add a little invalidate command. Just because it's going to be a mess to try and port all that code over. So this will just call invalidate instance invalidate. Obviously, if this is called though from outside this class, it should do the render submit, so it probably isn't 100% good to keep it like this for now, but whatevs. Now the Vulkan device, we don't need here anymore. We need it here. This is image data. Size, we can... Yeah, size is this now. And everything else maybe works. Alright, so maybe now we have a texture. But now to set that up and to use it, how would we do that? So we need to have a descriptor set. We need to write a descriptor set which does basically this. And is that it? Probably not. That seems too easy. This is Christmas music again, every time. Alright, let's switch this up to like the piano stuff. I like that as well. Classical piano, how about that? Hey, we're rocking now. I mean, as far as descriptors go, yeah, so this is kind of the important stuff that we need to think about, I think. So we need a descriptor set layout binding, we need a descriptor pool size to actually... Apparently there's 2 pool sizes here, interesting. I think I had 1, didn't I? Maybe that's because I had... Yeah, I definitely had 1 pool. Create descriptor pool. Does he really do that twice? No. There's still 1 descriptor pool. It's just that there are 2 pool sizes that go into the create info. Which I'm also doing, yeah. Alright. Okay, so we've got a texture now. So I guess what we'll do is we'll hard code this to try and read a texture, just so that we can see what's required for it. So we can get rid of this, and then I can hopefully just do I have to do layout binding equals 1, I guess, here, and then this will be a sampler 2D, uniform, I guess, sampler 2D, we'll do u_texture, and then we can try and sample from that. How do you do that again in OpenGL? So texture, or in GLSL texture, u_texture. We need the texture coordinates. Do that for now. Guess we can do that. I guess we can do that. Let's go to delete them not from the cache. Okay, so now instead of having a uniform buffer descriptor, so we'll leave this for like for the sake of when we do the reflection stuff, descriptor type combined image sampler 1. This is in the fragment shader. types need to change. This needs to change, I imagine. This is interesting. And then the types, where are the types? Here they are. So one of these. And one of these. That's 2 full sizes. What? Full size count 2, but why? That's an array already. All right, done, maybe. Let's not create a second uniform buffer. Don't really need to do that anymore. And the last thing is the right descriptor sets. So again, right descriptor sets, this needs to actually know the descriptor of the texture, right? Which is why I say we can't do this here. And I think I've said this before. I have said this before. Because this needs to be done basically per object or per entity or per like entity that you want to render. Per mesh, we'll say. So for now, we're going to do it this way. We're going to go into the test layer, because that's our testing layer. We're going to say, we're going to try and write the descriptor set here. So, can we do that? Well, I mean, of course we can, but how do we do that? So, where is the device and everything? Because we definitely use that here. Anyway, here's our descriptor set, which we get from here. I do want to leave that there. Do we not do anything from the device here? Maybe not. Maybe we just get the swap chain. Okay, that's okay. Oh, but we don't want to do this every frame, actually. So let's move this. We can do this in onAttach. Okay, so to get the descriptor set, don't know if we need the pipeline layout, but we can do that. We need the shader. I don't know if we need the, oh, that stupid way of getting the context as well. We've changed that, I think, made it easier. Oh yeah, we do need the pipeline to get the shader, of course. And then we need the device, which if we go to texture, we can see how we can get that easily. That's what we can do. Although I think we did it. Oh, it doesn't matter. Oh, like this. That's what I wanted. Test layer. Thing is, we do need this. So we need to set up all the descriptor sets at once. We can't just add a texture one. I guess we can't. Oh, but we didn't want to. So we need to get the uniform buffer from the shader, maybe. Yeah, okay. No, that makes sense. Don't worry. I just misunderstood something, which is classic. Get descriptor set. Let's do. Do that. So now we can, and obviously this is not going to stay inside test layer. But we can now do that. Now this is going to be a combined image sampler, and we need to get the descriptor from the texture, which I think if we look over here, texture descriptor, this is what it is. Descriptor image info. And this is just a descriptor image info, which is the same thing as that. Descriptor image info, yep. Okay, so we clearly need to know, okay, this is, I don't need these comments. Okay, so we need texture view sampler image layout. And then this texture descriptor is obviously what this becomes. All right. And then device is Vulkan device, and we can write the descriptor sets. It's not happy with you. Why is it not happy? It should be happy. Oh, it's buffer info. What? Image info instead of buffer info. That's what it is. Okay. That's it. So the texture now, let's create a texture. Texture equals new, no, we don't do that. Texture 2D, create. From a path, assets. Let's see if we can get that the checkerboard texture, eh? It's an editor checkerboard. Just because that's something that we can easily, hopefully, use on our weird geometry that we're rendering at the moment. Ref texture 2D, texture. We'll do that, and then we can just do this. So we need the texture view sampler and image layout. We could probably just ask it for, hey, can you give me the Vulkan description of it? So ref, yeah, that'd be better. Vulkan texture 2D. Texture equals that. I mean, we do that stuff, but I think instead of maybe handling it like that, we can just have a descriptor image info for it. Let's do that. Because and that way we don't need any of this. And what does that hold again? That holds a image view, a sampler, and an image layout. So an image view, a sampler, and an image layout can all be stored inside here. So let's go and see the errors now, and let's just patch them in. Here they are. Oh, well, this is for this destruction stuff. Image view. Image. Oh, the image is actually still image, I think. Sampler. Where's the rest of this stuff? It's worrying that it's not coming up as an error. What? Oh, it is good. That's it, I think. Yeah, so now, instead of having this junk, we can just say texture descriptor equals texture get, like Vulkan descriptor info. How does that work at the moment? Let's have that return it is a struct, so we'll have it return a const Struct here. Although, maybe const isn't the best idea. This probably won't work. I suspect this won't unless there's a const. Oh, it is beautiful. All right. That's it. Maybe. Maybe we now render a texture. As simple as that. Now, yeah, I don't. As usual, I feel like this isn't gonna work, but we'll see. Turkey. Alright, what's your problem? Access violation rating 070. Oh. Some kind of memory issue. Oh, that's wrong. Oh, where are we doing the texture stuff? Here. Ah, why didn't that assert? We didn't add a Vulkan texture. Yeah, this should really assert, shouldn't it? Like, what do we do with, like, what do we do in pipeline? Oops, not this one. This is what we should do everywhere. It's nice that OpenGL and Vulkan are the same number of characters, everything lines up beautifully. That's why I picked Vulkan over DirectX. Actually, nah, one too many and 3D ruins everything as well. It's funny. Oops. Oh, texture cubes. We don't support that yet. It's gonna be a long time before we support texture cubes. Well, probably not that long. I mean, we need them, but, you know. Priorities. Alright. Maybe that's good now. F5. D3D11 or D312. I guess that's what we would do. Cannot instantiate abstract class. Yeah, alright. Fair enough, bro. Fair enough. Let's see what we're missing. Probably a comparison operator. Or maybe a lot of this stuff. I don't want any of this stuff. Do we really use all this stuff? So much stuff here. Oh, it's too short. I didn't even bother counting. Yeah, it's 5 letters. We need 6, I think. We should know the format, shouldn't we? Should probably like implement some of this stuff elsewhere, but it doesn't matter. Let's return true for that. Resize, lock, unlock. That's for writing too. We don't need that. F5. D3D X11. That's funny. We don't have a constructor that takes 4 arguments. What even is that constructor? It's the 4 arguments. Oh, that's actually cute. It's this one. I think we also need that argument in there, even though I don't plan on using it at the moment. I think that was, well, yeah, we don't support that at the moment. Let's just stick a little core assert here to make sure that we don't hit that. D3D_11, that's disgusting. No, it can't be done. I wonder why they called it Vulkan. Whose idea was that? Who woke up and was like, I'm gonna make a new rendering API, we'll call it Vulkan. Channels is 3 instead of 4. What a disaster. But I'm telling you to make 4. Okay, well, I suppose that we could tweak this code so that it supports 3 channels, because I do want that checkerboard texture. Or we could re-export the texture. So let's just do 3 channels. Nah, whatever. And is that the only place where we have to do that? Is there any other texture format, like situations? I guess not. And the size should be correct, because I think we set the size to be ×3 here. Maybe that will work. Probably should deal with compressed textures and stuff like that. Did I change that? Thought I did. Oh well. Lock and unlock implemented via like fences or semaphores. I'm not sure at this point. We'll see how the synchronization works for that. Too early to think about that. Oh, a little debug callback. That's cool. It's always fun. VK create image. RGB unorm is not supported for this combination of parameters. Okay. Why not? And where is that coming from? So it's not supported for these combination. For this combination of parameters and physical device image format properties. Is this the thing where you have to have an RGBA texture in Vulkan? I think I don't know why it's jogging my mind. It's slightly something that I'm remembering, but each of the following values must not be undefined. Image create max MIP levels. Do we have that stuff undefined? And in that case, is it here? Where are we? We're here. MIP levels 1. That seems reasonable. Width height 64. This is for all the MIPs that we'll eventually do. Okay, let's just try an alpha channel texture. Because I do remember something about that not working. Is this, can we see? 24 bit depth. Is that bad? Okay, you know what? Textures, debug, and then we'll stick in checkerboard RGBA. Oh, excuse me. In the meantime, sorry again. Maybe let's save that as a PNG as well. I don't think it needs to be. Don't think it needs to be like that. So PNG, save. That probably still doesn't contain 4 channels though. Yeah, image mode. How do I make it have 4 channels? RGB. How do I give it an alpha channel? Mode. I don't remember, to be honest. Was that in the export settings? Well, it's grayed out. Why? Okay. This is Photoshop's checkerboard, but still only got RGB. Why is it not RGBA? What if I specifically have some transparent stuff? Is it really going to save it as RGB? Where's my alpha channel, dog? That's very weird. Oh, okay. Let's that's really annoying. Yeah, it's because of PNG's weird alpha support situation. Okay, you know what? This is dumb, but let's edit. Is that gonna be there now? Probably not, right? Oh my goodness gracious me. We just got textures working first try. Like, what did we fix? Just the format that was wrong. But like, damn. Well, that was easy. I guess it does have 4 channels now. Alright, so 3 channels suddenly don't work. Yeah, I think I remember something about that. Vulkan doesn't support 24-bit image formats. Yep. Alright, that's crazy, okay. I mean, the thing is, how would we do multiple textures, though? I guess that would be a problem as well. I mean, and by multiple textures, I don't mean for one object, I mean for multiple objects. I'm not really sure how we would do that, because clearly what we're doing at the moment is we're writing descriptor sets inside this kind of situation. Yeah, and then we're binding a descriptor. So do I really want everything to have its own descriptor? I guess that's fine for a mesh to have a descriptor then, right? Because then if a mesh has a descriptor set, then obviously we would just be like, hey, mesh, please give me this. And what does it need for that? So it needs to have what looks like a pipeline, essentially, because it needs to get the descriptor set from the shader, which we get from the pipeline. And that's fine, because if you actually look at mesh, in OpenGL, we were actually creating pipelines inside the mesh class, because that's the pipeline for how you want to render that specific mesh. So that sounds good to me. Like, I can see that working out. But the thing is, yeah, so textures have to be RGBA. We have to remember that. Vulkan requires RGBA textures. And then... yeah, okay, the material system, porting that across is going to be a little bit of work. But yeah, I kind of get this now. This seems pretty straightforward. Okay, let's try and render something a little bit more beautiful. Let's try and render the Cerberus, and we'll use that as our new kind of test, maybe. Let's see if that works. Then I'm probably going to take a lunch break fairly soon. I want to try and add another, and obviously adding this stuff in from the shader is going to be good. Alright, so let's take this, and then now let's try and load an actual real texture, and then we can, because the Cerberus should actually have textures like inside the model file, like the model file should reference these textures. So this is Cerberus, mesh of Cerberus textures, and then that, so we'll do, I don't know if they're RGBA textures though. And then I guess we can add like a normal map to it as well. Just to see if we can get 2 image samplers working, and then from that stage I guess we'll just go full PBR. Going full PBR is problematic though because of the, well, mostly because of the image-based lighting, which requires cube maps, which we don't have at the moment. Is it really 3 channels? So apparently if we open this with Photoshop, which we can't do, if we open this with Photoshop and then just save it. Somehow that last time saved it as a 24-bit image. I mean, more color channels. I'm not sure that will do it again. No, I didn't. What if I do that? I don't want to do the RGB to RGBA conversion myself. Why would I do that? It should be in the asset already. Why Photoshop? Why did it work for the checkerboard texture when I did it and it doesn't work for this? This might have more export options. Yeah, PNG with transparency. So that should probably be better. Although that's kind of annoying to go through this. We can probably see by the file size, maybe. 15 meg. Is it still going? Nah, it didn't do anything. Oh, here it is, untitled. Yeah, that looks bigger. Yeah, maybe because I made it transparent when I made a new file. I don't know. Anyway, whatever. This should work, right? Yeah. All right, cool. So we've got our little textured model now. And as my final trick, I'm going to test out multiple things by getting this normal map to work. So we'll do the export again. Export as. Takes forever. I just wanted to test that multiple textures are working. This will be binding 2. I guess we can do 2 though here, right? Descriptors, 2 descriptors, but then they have different bindings, so... Whatever, I'm sure this will work as well. Maybe that's if it's an array or something. I don't know. Same binding. I guess that would make sense. Anyway, so with that in mind, and we're loading the normal map now, let's try and just display the normal map. So if we go to... Oh, and do we need... Yeah, we need extra stuff in the shader, obviously. So this is the part that we want to automate by using reflection. Because at the moment, we have this here, and we have binding 2. And this is obviously getting annoying to have to do this. So there's 3 of them now. And then we also have another type. We could probably, I don't know, maybe this 2 would work here. I don't know if that... Let's try to do it like manually. Even though they're the same type and stuff, because that way we can make sure that it works, right? And then I think that's it. That should be it. So back in... Was it Vulkan test layer? No, we wanted to go back to our shader actually. So inside our shader, we can do the normal map now. I just want to sample from the normal, from the normal map. Quickly delete that cache. Why is it taking so long? Took a very long time. And then I'm not seeing the normal map. Why not? Oh, I know why. I know why. It's because this is still doing texture. Whereas this is the albedo texture. So it was getting the descriptor set from the first texture. Whereas this is the normal map. So normal texture is what we want here, and albedo texture is what we want there. There's our normal map. Alright, and finally, for the final trick, let's quickly make the normal map actually do something. So I'll just speed this up. I'll just copy this from the PBR shader. Let's see. So this actually does world normals, I think, which we need. Let's pop this here. Okay, so not using the normals in here at all. Actually don't need to output them at all. But anyway, let's see if we now maybe render with normal maps. Sorry guys. Everything else should be good. It's not gonna seg fault. Why would it seg fault? If anything, it's gonna assert. There's no MIPS or anything. Okay, that doesn't... Is that normal mapped? Yeah, I guess it is. It's hard to tell with this stupid lighting that I'm doing, but... yeah, it definitely is normal mapped. Alright, cool. You can see how bumpy that is. Cool. So we're rendering this with an extremely simple shader. But yeah, we've got multiple textures working. There you go. Okay. So I guess next step is like... Meta Potato, glad you're enjoying this. I'm enjoying this as well. This is going, it's going very smoothly this Vulkan week. I mean, as I said, I have done Vulkan before, so it's not like it's completely new to me. But it has been 10 months, and I don't think I've ever gotten this far with it. Like in terms of, by this far, I don't mean practically, like what you see. I mean in my head, the way I understand things. I definitely don't think I've understood Vulkan as much as I do right now, so. Glad you guys are enjoying the streams. I'm gonna have to break your hearts and say that I'm gonna take an hour break in a minute. We might do one more thing. Maybe I'll take it in 10 minutes, but I haven't had breakfast yet, and it's like 12:40 p.m. and I want to have some breakfast and relax for an hour, and then I will be back for another 3 to 4 hours of streaming probably. But before we do that, let's quickly change our shader to actually generate this stuff for us, right? Because at the moment we have to do this stuff. I don't want to do this stuff. So we have constant buffers. We have, let's do resource, sampled images, separate samplers. No, sampled images probably. How do we do this in OpenGL? In OpenGL, we use sampled images. Now we don't need a decoration. Oh, sorry, the binding, yeah. I thought that was a layout. It's the binding, it's good. We'll put name up here as well. Okay, so we've got, so we should have a bunch of sampled images now, right? We have to store them somehow, obviously, but the point is if we have this stuff and we've done the reflection, and remember, I think I might do the reflection in 2 stages. I might actually do the reflection, basically parse the reflection, like everything we need from reflection, put it into my own data structures, and then in Vulkan go iterate through my own data structures and then set the stuff up. Now it might seem counterintuitive to do it twice like that, but the reason is that eventually this stuff will be done offline. Like if you're not using Hazel as an editor, if you're actually playing a Hazel game, then you don't want to waste time during startup parsing shaders. Like that should be done offline. It's not like the shaders are going to change. So because of that, eventually this stuff will possibly be moved offline. And then that way at runtime, we can just get the data we actually need a lot faster. So yeah, so that's how it's going to work. So layout bindings. So what we need to do is, and what I will do here is this. OpenGL, I think in OpenGL I was doing something similar. Like we did have uniform buffers, right? We had these little, yeah, we had uniform buffers, and I think we had them static, and they were by name as well. Sorry, by binding. So that's probably fine. Now, the thing is, for Vulkan, though, I want to probably have layout bindings, because what do we need? We need layout bindings and then type counts. Oh, before we do this, let's try and change this. Although, I guess we don't have to, and I probably don't care too much about that, to be honest. Is it okay if we miss a binding? I guess so. This is just the max amount. Let's see. So this works. Let's see if we reduce this to like 2, right? So we'll do 2. That'll be 2. That'll be 2. Does this work? Because that way, like, I mean, yeah, why would we have, you know, multiple like that? This is just the total amount. Like, we don't need to know bindings or anything for these descriptor pools. In fact, I'm not even sure if what are the descriptor pools used for? Yeah, for allocating descriptor sets. Now, I did say these shouldn't be in the shader class, but I don't know if this probably should be. This has nothing to do with actual data. This should be, I think. Yeah, that still works as expected. Okay, so let's think about this. So, when we go over a uniform buffer, which is here, we want to probably push that back into here, but we still need to create a descriptor set for it. So we still need to know actually what uniform buffers are used by this specific shader, or at least in Vulkan. In OpenGL, you probably don't care too much about that because there's no descriptor sets to allocate. So I would like to know this shader's uniform buffers, and I think that will be, again, I'm going to store that probably as an unordered map of binding point to uniform buffer, which is actually maybe shader uniform buffer. Name, index, binding point, size, render ID. Okay, this needs to be refactored. What's uniform buffer anyway? It's got the actual uniform buffer stuff. I guess I could just chuck in a binding point. 0 is valid though, so maybe not. Why is this upset suddenly? Oh, because of that. Yeah, we'll just do that. Alright, and then as I iterate through this, I can probably fill that up. So we can just say that uniform buffers at binding point. I can definitely assert and make sure that we don't have that, because then we have a duplicate index. So and I don't know if, again, maybe we don't need to store this as uniform buffers and samplers separately. Maybe we can just store them as resources, because that's what they are. But you know, it's lots of different ways to do this, and until I actually write the PBR renderer properly, I don't think I'll be able to see what the best thing is to do. So why is it so keen to be a pointer? What does it think this is? Oh. Oh, okay. This. So this doesn't really need to exist anymore. Yeah, that's still valid. So M uniforms at binding point. Let's do this instead. And then I guess we can, what do we need? The binding point, which is also the index of the map. Size. What else isn't in this? Descriptor memory buffer. Yeah, we don't need anything else for now. All right, so that's it. We've added that in. Push constants, probably not gonna worry about that for now. Oh, we don't even do anything with that, do we? Not yet. That's in the pipeline. So now that we've got that, right, we should be able to go through all of the uniform buffers. We could also easily keep track of this kind of stuff already. Like, it's pretty clear that, like, oh, how many uniform buffers do we have? How many samplers do we have, right? So, for example, this, you know, layout bindings uniform buffer. So we could easily just say, sorry, this is layout bindings. That's not what I wanted. Where are the types at? Type counts for descriptor pools. This might be the first thing I make, actually. The descriptor pool before I do the descriptor set layout. So we don't know how many type counts there are at the moment. Well, no, 2 is fair, I think, actually. So yeah, we can do 2. So we can do this. So if uniform buffers dot size, right? So we have more than one uniform buffer. Then we can, yeah, but what if we don't have any? We'll do this for now. Maybe we can allocate that a little bit differently. So in that case, let's push back a one of these puppies and place back. And then we'll just do, well, let's just do that. Oops, that's that. We'll just do that. All right, and then descriptor count obviously is going to be uniform buffers dot size. So now we have the correct amount of that, and then we have to do the same thing for images, right? So we'll just do image sampler because they're called combined image samplers. We'll definitely have more than that eventually, I think, but you know, for now. Okay, so we should have this correct now. Now, next step is type counts dot data, I think is what we want, and type counts dot size is what we want here. So that's done. That's the descriptor pool done, hopefully. Now with reflection data, okay, layout bindings. Now this is also something that we need to make dynamic here. And as I said, it kind of hurts me a little bit to use the vector here. I guess it doesn't matter too much. It is like initialization code, but still. All right, so now at this point we have to go through all of the uniform buffers and all the combined image samplers again, but actually this time iterate through them. So let's do this. So for auto binding uniform buffer m uniform buffers. And then we do the same thing for binding image sampler. And then we simply do layout bindings in place, back, Then we can get a reference to that. I guess we can make it a little bit layout binding, get a reference to that. And then we simply do this, but like that. Okay, which stage it's in is going to be important actually. So we're not dealing with that. Now the count, yeah, we're doing that because they have different counts at this stage. And then binding obviously needs to be binding. But I think everything else should be okay. And then we can do the same thing for image samplers. Except this is a combined image sampler in the fragment. So yeah, we need to know what domain they're in. Obviously it's possible to have uniform buffers in the fragment shader as well. And that's it. Yeah, that's pretty easy. All right, let's get rid of that. I definitely should have committed before I started doing this, now that I think about it. I feel like that's a pretty dumb move from me, but it's okay. I think I understand this pretty well. That's what they all say though, I bet. Now we don't have any image samplers though at the moment. So let's do image samplers. Well, we'll do the same thing we did here, right? Which was this. Is that really all we need? The binding point? Surely not. We need to actually create a uniform buffer as well. Yeah, let's try and automate that, I guess. Oh, well actually, this stuff happens kind of automatically. So we just do, because we've got the uniform buffer, so I think since we've got it, right? Oh, create tries to return an entirely new one. Oh, okay. Okay, here's what we do. This becomes void. So what do we need from it, actually? We need the descriptor, the buffer, and the memory. Right, so let's make this happen. Let's make these output variables. Or we could actually, sorry, way better, take in a destination uniform buffer that already exists. So now, if we hop on over here, easy. Solved. Let's do that. That's it. I actually think that it's not even comprehending it. IntelliSense is just frozen. Yeah, I think that should maybe work. So if we do that, then all we have to do is actually call create uniform buffer. Size is, oh, we don't even need the size. Size is already set, actually. So we just literally can pass in the current uniform buffer, and it will actually allocate it. So we should probably call this allocate. Let's do allocate. Allocate uniform buffer. This goes away. The size we're now getting from the shader as well, so sweet. This goes away. Let's get rid of that. It's called allocate now, and it doesn't return anything. So let's get rid of that. That's why it was erroring us. And then the size we get from uniform buffer.size. Well, actually, yeah, we don't need to set that. It's already set. We just use uniform buffer.size where needed. And we don't return anything. Okay, and we should now have a uniform buffer that exists. Amazing. All right. And then we should have that as well. And then what else needs to be done? Is that might actually be it. No, that seems too good. Too easy to be true. I mean, we're not doing anything hugely complicated, but I'm scared. Let's just hit F5. This is so not gonna work. All right, we've got a little debug callback. We missed something apparently. And this happens in, whoops. Yeah, in pipeline and validate. Oh, well I think maybe we're just not getting it properly. At this stage, right? How is it figuring out everything that we're using? Or is it not? What is it trying to take from Vulkan shader? That's what I want to know. The descriptor set layout. Yeah, okay, I think we should have created that correctly. Alright, I'm gonna give this another 4 minutes maximum. And then I'm bailing to have breakfast. Okay, I think we might have to walk through this, to be honest. Just because I don't trust that I didn't make a typo or anything like that. It's very, very possible. Alright, uniform buffers, we've got 1 uniform buffer. No image samplers. What? Oh, we're just doing the vertex shader. That's why. Lol. We're just doing the vertex shader. Ah, we need to split up. Okay, easy. We can just do it per stage. Alright guys, break's coming now. I'm gonna turn the stream offline obviously for the break. But thank you guys for watching. I'm gonna take a 1 hour break. So at 2 o'clock I will be back. 2 o'clock Australian Standard Time. Look at your clocks. In 1 hour I will be back. Yeah, and then the rest of the day we're going to probably make sure the shader reflection works perfectly, and then maybe we can get the PBR shader up and running excluding cube textures and the whole compute shader situation, because I don't think that's gonna work. But otherwise I'm pretty happy with how everything's happening. And then maybe like with command buffers, and there's a few other things we need to move away from Vulkan test layer into other classes. But thank you guys for watching. See you in an hour. And yeah, have a good time. Have a good break. You all deserve a break as well. Goodbye.